Have you ever wondered what makes neutron stars so unique? These cosmic behemoths are not your average stars. Born from the dramatic death throes of massive stars, neutron stars are the remnants left behind after a supernova explosion. Imagine witnessing the dramatic transformation of a celestial giant, its last breath lighting up the cosmos and leaving behind a core so dense and exotic, it defies our everyday understanding of matter. That's the birth of a neutron star. These compact stars are the lighthouses of the universe, their pulsations serving as cosmic timekeepers, their laboratories of extreme physics, testing our understanding of the universe's fundamental laws. From their mind-boggling density to their astonishingly rapid rotation, and from their powerful magnetic fields to the intriguing phenomena of starquakes and pulsar glitches, neutron stars are a treasure trove of cosmic mysteries. Let's dive into the world of these cosmic giants and explore 10 things you probably didn't know about them. Firstly, let's talk about how neutron stars are born. It's a process that's as thrilling as it is cosmic. Picture a star, much like our sun but several times bigger. As it burns through its fuel, a fascinating transformation takes place. The star swells, becoming a red giant, and then it begins to collapse under its own weight. This collapse triggers a supernova, a colossal explosion that's one of the most spectacular events in the cosmos. The supernova is so bright that it can outshine an entire galaxy for a brief moment. But what's left after the dust settles? The heart of the original star, now compressed into an incredibly dense core. This core is the newly born neutron star. It's about the size of a city, but don't let that fool you. It's so dense that a sugar cube-sized piece of it would weigh as much as a mountain. And it spins, oh how it spins, up to hundreds of times per second, generating a magnetic field 1 trillion times stronger than Earth's. The birth of a neutron star is not just the death throes of a giant star, it's a rebirth. A stellar phoenix rising from the ashes of a supernova, ready to live a new life as one of the universe's most extreme objects. So, the birth of a neutron star is essentially a rebirth from a stellar explosion. You might be surprised by how small, yet incredibly dense neutron stars are. Picture a city, let's say Manhattan. Now imagine cramming all the mass of our sun into that city. That's roughly the size of a neutron star. They're typically about 12 miles in diameter, making them significantly smaller than our planet, yet they contain more mass than our sun. Now let's talk about the density of these cosmic giants. Picture a sugar cube, the kind you might drop into your morning coffee. Now imagine that tiny cube weighing as much as Mount Everest. Yes, you heard that right. That's because the density of a neutron star is something out of this world, literally. If you were to scoop up just a teaspoon of neutron star material, it would weigh about 1 billion tons here on Earth. That's about the weight of all the cars in the United States combined, and all that is packed into a volume smaller than a teaspoon. Incredible, isn't it? So you see, neutron stars are a marvel of cosmic proportions, a testament to the extreme conditions that exist beyond our planet. They challenge our understanding of matter, gravity, and the very fabric of the universe. So in terms of size and density, neutron stars are truly extraordinary. Neutron stars spin at an incredible speed. Picture this. Some of these stellar remnants whirl around their own axis hundreds of times every single second. That's faster than the blades of a commercial blender. Now, that's what we call rapid rotation. This spinning is not just for show. The rapid rotation of neutron stars plays a significant role in the creation of their powerful magnetic fields. As these stars spin, they generate an intense magnetic field that extends far into space. This is similar to how Earth's magnetic field is generated, but on a much grander scale. The speed of this rotation, coupled with the intense magnetic fields, makes neutron stars some of the most fascinating objects in the cosmos. They're not just spinning tops in space, they're a testament to the extreme conditions that exist beyond our planet. Their rotation is so fast, it's almost hard to comprehend. But that's the beauty of neutron stars. They continue to astound us with their extraordinary properties. Neutron stars have incredibly powerful magnetic fields. Imagine a force so strong that it's about 1 billion times stronger than that of Earth's. Yes, you heard it right, 1 billion times. This is the magnetic prowess of a neutron star. Let's break it down. Magnetic fields are generated by the movement of electrically charged particles. In the case of neutron stars, these intense fields are a result of the star's fast rotation and the movement of superconducting material within them. The magnetic field of a neutron star is so powerful that it can cause the fabric of space around it to warp and twist, creating phenomena known as magnetars. These are neutron stars with the strongest known magnetic fields in the universe, fields so powerful they could wipe out data on a credit card from thousands of kilometers away. So, next time you think of magnets, think bigger, think 1 billion times bigger. The magnetic fields of neutron stars are some of the strongest in the universe. Neutron stars are also known as pulsars. This may sound like a name straight out of a science fiction novel, but it's rooted in the reality of these celestial bodies. Pulsars earned this epithet due to the beams of radiation they emit. These beams are not random, but rather the result of the star's rapid rotation. As the star spins, it shoots out streams of electromagnetic energy. When this energy is directed towards Earth, we perceive it as a pulse of light or radio waves. This is similar to the rotating beam of a lighthouse appearing to blink as it turns. The frequency of these pulses is incredibly stable, often compared to the precision of an atomic clock. Some pulsars rotate hundreds of times per second, and the regularity of their pulses allows astronomers to measure time and distances with great accuracy. However, not all neutron stars are pulsars. To be classified as a pulsar, a neutron star's beam of radiation must be detectable from Earth. So, while there may be countless neutron stars spinning and emitting energy into the cosmos, only a fraction of them are visible to us as pulsars. Pulsars are more than just celestial oddities. They are invaluable tools for astronomers, providing insights into the nature of space-time, the interstellar medium, and even gravity itself. Pulsars are like cosmic lighthouses, signaling their presence to the universe. Yes, neutron stars can have starquakes. Unfathomable as it may sound, these stellar tremors are a fascinating aspect of the cosmos. Starquakes occur when the crust of a neutron star undergoes a sudden adjustment, much like the tectonic plate shifts that cause earthquakes on our home planet. However, it's important to note that starquakes are not your run-of-the-mill earthquakes. They result from the extreme gravitational forces exerted within neutron stars. These forces are so immense that they can warp the star's rigid crust, causing it to crack and shift. Imagine for a moment the crust of a neutron star. It's about 1 million times stronger than steel. When this super strong crust cracks, the star's surface shakes violently, releasing a tremendous amount of energy. This energy is so vast, it can cause the star to momentarily speed up its rotation. It's also worth mentioning that these starquakes can give rise to what are known as glitches in a neutron star's rotation. We'll get to that intriguing topic shortly. To sum up, starquakes are a captivating phenomenon that showcases the extreme conditions within neutron stars. They provide a glimpse into the raw, untamed power contained within these dense stellar remnants. Starquakes are not just about seismic activity in a star, they are a testament to the profound forces at play in the cosmos. Starquakes are another testament to the incredible power of neutron stars. Pulsars can experience what astronomers call glitches. Now, don't let the term fool you. These aren't errors or malfunctions. Rather, they are sudden changes in the rotation speed of a pulsar. Imagine a top spinning at an incredible speed, then without warning, it spins even faster. That's essentially what a pulsar glitch is. These glitches are believed to occur due to the internal structure of the pulsar. Picture the inside of the pulsar as a superfluid core surrounded by a crust of superdense matter. Now, this superfluid core can rotate independently of the crust. When the core's rotation slows down, the crust can abruptly catch up, causing the pulsar to spin faster, hence a glitch. These glitches, though strange, offer invaluable insights into the internal workings of these celestial bodies. They give us a glimpse into the extreme conditions inside a neutron star. Pulsar glitches add yet another layer of mystery to these fascinating cosmic objects. Believe it or not, neutron stars could be the universe's gold factories. Now, that's a statement that might raise a few eyebrows, but let's delve into the fascinating world of astrophysics to understand this better. When two neutron stars collide, they unleash an astronomical spectacle known as a kilonova. In these cataclysmic events, the extreme temperatures and pressures are just right to create heavy elements. But how does this happen? Well, it's a process called rapid neutron capture, or R process for short. The R process is like a cosmic assembly line where neutrons are rapidly captured by atomic nuclei, creating new, heavier elements. Now here's where things get interesting. Among the elements forged in this stellar forge are precious metals like gold and platinum. Yes, that's right, the gold in your wedding ring, the platinum in your necklace, they might have had their origins in the violent collision of two neutron stars billions of years ago and light years away. But these cosmic factories don't stop at gold. They churn out a whole array of heavy elements, filling the universe with the building blocks necessary for planets, life, and even us. So the next time you marvel at a piece of gold jewelry, take a moment to appreciate its celestial origins. It's not just a precious metal, it's a tiny piece of the universe, a testament to the incredible processes happening in the depths of space. Next time you wear a piece of gold jewelry, remember, it might have come from a neutron star. Neutron star collisions are among the most powerful events in the universe. Now, what exactly happens when two of these incredibly dense celestial bodies meet? Well, the dance begins long before the actual collision. These stars, each one more massive than our sun yet compacted into a sphere just about 12 miles across, start spiraling towards each other, shedding energy in the form of gravitational waves. These gravitational waves, ripples in the fabric of space-time, were predicted by Einstein's general theory of relativity. But it wasn't until the 21st century that we developed the technology to detect them. Each wave that reaches us is a message from the cosmos, a testament to the immense power of neutron star collisions. As the stars draw closer, their combined gravitational pull distorts their shapes. The final moments are breathtakingly swift. In a fraction of a second, the stars collide and merge, triggering an explosion known as a kilonova. This event is so powerful that it distorts the very essence of space and time around it. In the aftermath, the collision spews out a cloud of superheated material. This is where the magic really happens. The extreme conditions foster the creation of heavy elements. Gold, platinum, and other precious elements we find on Earth likely originated from such cosmic cataclysms. The collision of neutron stars is a cosmic spectacle of immense proportions. So the next time you wear a gold ring, remember, it's a tiny piece of the universe, born from the death throes of stars. So, there you have it, 10 fascinating facts about neutron stars. Our cosmic journey has taken us from their dramatic birth in the fiery throes of supernova explosions to their unique properties that defy earthly comprehension. We've delved into the mind-boggling reality of their size and extreme density, where a teaspoon of neutron star matter would weigh about 1 billion tons. We've spun with them in their rapid rotation, felt the strength of their powerful magnetic fields, and experienced the tremors of starquakes. We've pulsed with the rhythm of pulsars and navigated the anomalies of pulsar glitches. We've even discovered their role in the creation of gold and witnessed the cataclysmic spectacle of neutron star collisions. These celestial giants are not just distant lights in the sky, but keys to understanding the universe's most profound mysteries. So let's keep looking up, keep wondering, and continue our quest for knowledge in this vast cosmic playground. Before we wrap up, we would like to invite you to become more engaged with our cosmic journey. If you've learned something new about neutron stars today, why not give us a thumbs up? It helps us to know that our content is enlightening and interesting for you. We're curious to hear your thoughts too. What surprised you the most about neutron stars? Do you have a favorite fact or a question that's been sparked by today's video? Share your thoughts and queries in the comment section below. We love to see your perspectives and engage in enlightening discussions. If you haven't done so already, please hit the subscribe button and press the bell icon. This way, you won't miss out on our future explorations into the mysteries of the universe. We regularly upload content that delves into the wonders of our cosmos, and you won't want to miss what's coming up next. Finally, if you know someone who shares your fascination with the stars, why not share this video with them? You never know, you might inspire them to embark on their own cosmic journey. Remember, The universe is a vast, fascinating place, and there's always more to learn. So let's keep exploring it together. Until our next cosmic adventure, keep looking up.